Uh, Hello and welcome to this recording on the time value of money. Last week we concluded on agency theory and what it is all about. Remember, when you delegate decision-making authority over your business to a manager, for example, they are unlikely to act in the best interest, in your best interest. They're likely to take some money to themselves, employ their relatives, and so on. That was the idea about agency theory. Before then, we had looked at the assumptions of finance and the definitions. So today, we go straight into the time value of money. So time value of money is one of the most fundamental principles in all of finance. You realize this particular topic, I regard it as one of the most important in finance. If you don't understand this, you'll have problem in your finance for the rest of your life, I could say that, because it is very, very central. So time value of money, what is it all about? The core idea is that money today is more than money tomorrow. And let's think of an example. Supposing somebody promised you 100 shillings today, immediately, available for you to spend, invest, or save, or do whatever you want. And somebody tells you they are going to give you exactly 100 shillings in 1 year's time. Which one would you prefer? In many cases, any logical person would prefer 100 shillings now, rather than wait for 1 year to receive the same 100 shillings. The reason is, if you remember from our assumptions of finance, we said people have what we call time preference. People have what we call immediate gratification preference. They would rather have their money now rather than have it later. This is the third assumption. If you go to the introduction, we did look at these three assumptions. People prefer more wealth to less. People prefer less risk to more. And people would rather have their money now rather than later. So this third assumption is what leads us directly to the time value of money. If people must delay gratification and wait for their money, they expect to be compensated for this waiting. So this compensation, like I told you, accounts for what we call the opportunity cost of not having their money available now to do what they want with it. They may invest it, they may consume it, and so on and so on. There are four fundamental reasons why TVM exists. We are going to call time value of money TVM moving forward. There are four reasons why time value of money is paramount. Number one is consumption preference. People by nature are impatient. They prefer to consume now rather than later. Number two is investment opportunities. If you are given your money now, you could invest it and earn some interest or some dividend or something else, whatever you imagine. You can invest it somewhere and get some return, some profit, or so on. Number three is inflation. Inflation reduces the purchasing power of money. So if you are given money today, it can buy more than the same amount could buy next year or next year but one. The final one is risk and uncertainty. If you are given money now, you have it in your pocket. But if somebody promises you money in the future, they could go bankrupt, or they could change their mind, or you see, in future there is no certainty. They could simply fail to pay you for a variety of reasons. So this is reason number three about inflation. Future money buys less. I don't think we need to overemphasize that. So it is better that you have your money now. For example, if you estimate 100 shillings in 1980 could buy more goods than 1,000 shillings and above today. So imagine somebody promised you 100 shillings in 1980, but they said they are going to give you today you are losing a lot. The 100 in 1980 is not equal to the 100 shillings today. 100 shillings today is worth far less. The other reason we talked about risk and uncertainty, that is the reason why time of value of money exists in some cases, because somebody promises you money next week or next week but one, they could fail to give you that money. Why? For a variety of reasons. They could default, either they become bankrupt or whatever else, and or maybe they have a business where they were going to get that money and give you. The company fails to generate enough cash flows, so they are not able to give you that money. So money in future, there is an inherent uncertainty that it may not be paid to you. And the implication is, if you have to wait for money in future, you have to be compensated for all these matters now. You have to be compensated for the opportunity cost of not consuming now. You have to be compensated for the investment opportunities that you missed. You have to be compensated for the erosion, the purchasing power erosion of inflation. You have to be compensated for the risk and uncertainty. So that is why time value of money exists. So time value of money is one single idea, but very, very powerful. Very, very powerful. Like I said, I consider this the single most important topic in the whole of finance. So let us start by doing the computations now. How do we compute the future value of a lump sum? It means if you are given 100 shillings now and you invest it at a given rate of interest, maybe you put it in a fixed deposit account, how much money will it be in a number of years to come? Let's call it 2 years, 5 years, or 10 years. So that is the idea of future value of a lump sum. A lump sum means a single amount. If you are given 100 shillings, invest it at 10%, how much will it be in 10 years, in 15 years, in 20 years? And in this case, we will be talking about compounding later on, and you see how it affects that. So this is what we call the compounding process. I gave you an example of 100 shillings. You invest it at 10%. After the end of year 1, you'll have 110. If you invest this 110, at the end of year 2, you'll have 121 shillings. If you invest 121 shillings, at the end of year 3, you'll have 133.10. Notice, if it was going to be simple interest, we were going to simply get 100 times 10%, which is 10 times 3. We were going to get an increment of 30 shillings. 100 times 10%, that is 10 times 3 years. 3 years, because this is the beginning. So we are counting for year 2, year 3, and year 4. So that is how it will be like. So this is a formula for computing the future value of a lump sum. The future value is simply the present value times 1 plus r to power n. Something I want us to note here, which may be confusing, is that we have a case of, and this is something I prefer to emphasize, so let me just illustrate that here so that we don't confuse anybody. I'm going to have a big pen and maybe white color there. So in our case here, you must remember that this is the beginning of time. For example, this could be January 2026, which is the beginning of the year. So the end of year 1, so this is the beginning of year 1. The end of the year 1 is also the beginning of year 2. So this is December 31st, 2026, which is the end of year 1. It is also the beginning of year 2. The end of year 2 is also the beginning of year 3. The end of year 3 is also the beginning of year 4. So never forget that. Remember, you cannot separate time into discrete. It is continuous. It will always be there. So note that the beginning of one period, the end of one period is the beginning of another, and so on and so on. So like this one, if you receive money at the end of year 1, it is like you are receiving it at the beginning of year 2. So compounding is going to start there, because you have received money here at the end of year 1. It is also the beginning of year 2. So that is one period. Then from there you come to the second period. Then you come to the third period. That is why here, although we have 1, 2, 3, 4, it is only 3 periods, because we are assuming we are receiving this money at the end of the year. And the end of one year is the beginning of another year. So just to clarify that, so that nobody is confused. So this is the general formula. Present value is future value is present value times 1 plus r to power n. We are going to see later that this portion here, we can read it from the tables. We can get it from some tables that you are going to be given, even in the exams, they will be there. So present future value is what we are computing. How much will this money be worth in 5 years, 10 years, 15 years? And notice in this formula, we assume you are not withdrawing your interest. Your interest is compounding. So you invest 100, at the end of year 1 you have 110 at 10% interest. So you don't withdraw the 10, it continues. So at the end of year 2, you are computing interest on 110. At 10% it becomes 121. The next year you are computing interest on 121, and so on and so on. So that is what we call, so this is what we call the compounding factor. It is called the compounding factor, or the growth multiplier, or it is also known as the future value interest factor. I think I have put it down here in the notes. It is a future value interest factor. Let's see an example. And again, this is something that is not very unfamiliar. It is something that you have done in the past, I'm sure. Compound interest, it is the same idea that of compound interest, nothing different. So don't overthink it. So you have 100 shillings today, you multiply it by 1.1, which is the 100% plus 10%. So you get 110%. So 1.1 gives you 110. Multiply that 110 by another 1.1, you get 121. Multiply 121 by 1.1 again, you get 133.10. Now let's see an example. Simple investment of future value calculation. You invest 500 shillings in an account earning 8% per year. You leave the money untouched for 5 years. How much money do you have at the end? So what we are going to have is, you have your 500 times 1 plus 8%, because your money is untouched for 5 years. This is a formula that we have there, and the answer will be 734.66 Kenya shillings. Notice our compounding factor. Our compounding factor will be 1.4693. That is our compounding factor, or the future value interest factor, which is this part here, which is that part there. So that is the compounding factor. I am highlighting that because this part here in future we will not be computing it manually. You can read this part from the table, from a table that we will be discussing in the next lesson. So, and we have the concept of compounding is very, very can make your money grow very fast. Look at this case where we have only 100 shillings invested at a constant 100%. At the beginning it grows very slowly, then it explodes all of a sudden. It explodes all of a sudden. So it is very, very compounding. Also, if the interest rates change, so if the interest rates also change, the money is going to compound very, very fast. So if somebody asks you what determines how fast your money grows when you are compounding it, it is very simple. If we come to our formula here, it is R, which is the rate of interest, and N. If any of these two grow, then there is a dramatic shift in your cash flows. So I hope that is okay. Let's look at the next part. So this is the true magic of compounding. So Albert Einstein, it is said that he said compounding is the eighth wonder of the world. And I have always told people that the moment you start your career, if you just put money in a circle, for example, most of these circles are very nice, like the teacher circles. They can give you around 12% per annum. If you are to invest that money in a circle when you are 24, you keep putting money in a circle. Don't remove the interest. Just assume this money is for retirement. Even if you put 1,000 per month after 24 years old, or 2,000, let's say, by the time you are retiring at 60, I can promise you will be a millionaire and you can retire very happily. But most people don't have that patience. Remember from our assumption, we said people prefer to consume now rather than later. I am a member of one such circle, and when the dividends are being declared, the following morning people are queuing at the door waiting to withdraw that dividend. I always tell them that is not advisable, because if you are to compound that money, if you are to reinvest that dividend 1 year, 2 years, 10 years, you'll have much more money because of the explosion we talked about. These two graphs tell you all you need to know. Okay. We also have the rule of 72. The rule of 72 is a quick way of establishing how many years would it take my money to double if I put it in a fixed deposit account or any other investment that gives you a fixed rate of interest, and you don't withdraw that interest, you keep reinvesting it. For example, if you invest your money in an account that earns you 8% interest, it will take approximately 9 years for your money to double, which is 72 divided by 8. 8 is 8%. If you invest it in an account that earns 12%, it will take approximately 6 years for your money to double. You see, if you put it in an account earning 6%, it will take approximately 12 years for your account amount to double. So we have a circle at in Karatina, New 40 circle. It pays around 12.2%. So it takes approximately 5 point something years for your money to double. If you keep just putting the money and you don't withdraw the dividends, after 5 years, your money will be double what. If you just put your money, if you just put like 1,000, after 5 years it will be 2,000. If you put $1 million, after 5.8 years it will be 2 million, and so on and so on. That is the power of compounding. Next, we go to the present value of a lump sum. We had that case Supposing somebody promises you 1 million shillings 10 years from now. How much is it worth today? How much is that 1 million worth today? Remember, we said a shilling today is worth more than a shilling tomorrow. So a million shillings 10 years from now is likely to be worth much, it will be much less. It will not be a million today. That is the idea of the present value. A million shillings 10 years down the line is worth maybe 800,000. 800,000 today is equal to a million shillings tomorrow, or something about that area. So how can we compute the present value? Remember, for future value, we are taking an amount now and projecting it into the future. Present value is the opposite. We are taking an amount in the future and computing the amount it is equivalent to today, given a rate of interest. And this is the formula. Present value is future value over 1 plus r to power n. I want to extend this one as follows. It is also equals to future value times 1 over 1 plus r to power n. And have just separated it so that the future value is separate, times 1 over 1 plus r plus n. What you see here is what we call the discounting factor, or the present value interest factor, PVIF. We will be coming across that later on when we are looking at the tables. So we think of compounding and discounting as the opposites of each other. They are mirror images of each other. So this is a timeline. For example, you are told, somebody tells you they are going to give you 133.10 shillings in 3 years time. How much is it worth now if the rate of interest is 10%? So to move it to this point, it is going to be 133 times 1 over 1 plus 10%. 10% is 0.1. So it is going to be 133.10 divided by 1.1, which will be 121. We do 121 again. It will be 121 over 1.1, the same idea, which gives us 110. We do it again. 110 divided by 1.1 gives us 100. So it's the same idea that we had before then. So let's look at an example. You are promised 100 shillings to be received 3 years from today. The relevant discount rate is 10% per year. What is this promise worth to you now? So this is present value. So we are going to say it is 100 times 1 over 1 plus 10%. It is 3 years time, and that is what we have here, 75.13. So what we have here is what we call the present value interest factor. We'll be seeing that in the next recording that we have. So this is also another example, the same idea of computing the present value interest factor. This is also another case that is very, very common, valuing a future liability. You have a debt obligation of 1,000 due in 2 years. Your discount rate is 8% per year. How much do you need to set aside today to fully fund this future payment? So how much do you need to invest now so that in 2 years you have 1,000? So it is simply the present value of 1,000 at 8%. In short, it is going to be 1,000 times 1 over 1 plus 8% to power 2. This is what we have there, 857.34. So that is also a very common example of thinking about that. So present value is the language of finance. We'll be looking at it when you are computing valuation, when we do valuation, when you do capital budgeting, and so on. So it is a very, very common tool. So I would just want to skip further to look at something else that is also very, very important, what is called an annuity. An annuity is a series of fixed payment for a given period of time that is paid regularly. Let me give you an example. You are paid 1,000 shillings at the end of every year for 5 years. One thing you realize with that, it is a regular payment. It is the end of every year. Number 2, it is a constant payment. It is 1,000 shillings every year. Number 3, it is for a defined period of time, 5 years. That is an example of an annuity. Or somebody says they are going to give you 10 shillings per day for 7 days. Again, that is an annuity. Fixed time, regular payments, it is on regular periods, it is 1 day in this case, and it is for a defined period, 7 days, and it is a fixed payment, whatever amount you are going to be paid. So examples are salary payments, rent and lease payments, loan repayments. When you take a loan, usually you pay a fixed amount every year for a given number of years. And bond coupon payments. Don't worry about the difficult term. We are going to define it much later. So this is an example of a cash flow timeline. This is a cash flow for 4 years. You can see the time is defined and the payment is constant. It is 100, and that's it. That's why it is an annuity. It is a series of fixed payment paid at regular intervals for a given period of time. If it is daily, it is daily. If it is weekly, weekly. If it is yearly, yearly. Monthly, monthly, like that. But then it is a fixed payment. And it has a defined period. It will be paid for 12 months, 16 months, 10 years, 20 years. There is a fixed payment period. So that diagram is very, very important. So how do we compute the present value and the present value of an annuity? Remember, we said the present value is the opposite of the future value. So we can do it one by one. For example, if we have 1,000 shillings at 10%, this is the example that we have here. This is at the end of year 3. We can take it back to year 2 by simply saying it is 1,000 divided by 1.1, which is what we have there, 826. Then we can take it down like that. We can take now 826 divide by 1.1 like that, which gives us 751, and so on and so on. So that is the mechanical way of doing it. You can just take it back each year, each year, each year, and so on. But we have a shortcut. We have a shortcut, which is very, very, very important. This formula here, I'm not going to read it out, gives you a way of computing that present value very, very easily. Instead of doing it manually, going back, you can use this formula straight on, and you get your answer. In our case, we are going to have 1,000 times 1 minus 1 plus 10%, the rate is 10%. I'm going to put it as 0.1 to the power n, which is 3 years. Remember, it is minus 3 minus n. Then we divide it by 0.1. This portion, which is also the one that is here, is what we call the present value interest factor of an annuity. Remember the other one? The other one was present value interest factor when it is not an annuity. Now we are moving to present value interest factor of an annuity. That one, the reason we are just putting 1,000 is, remember the definition of an annuity. It is a series of fixed payments. All of them are fixed. In case the payments are not fixed, you have no way out. You have to do it one by one, like we are doing here, in case the payments are not fixed. But as long as they are fixed, you just put that fixed payment here of 1,000 in our case, then you apply that formula, and you are going to come to the same conclusion. You are going to come to the same conclusion around 2,486. Remember, you put in 1,000 in year 1, 1,000 in year 2, 1,000 in year 3. It is a total of 3,000, but because of time value of money, the present value will be slightly less than 3,000. That is why it is 2486. So this is a timeline for a cash flow. I don't think it's very important. I think we have emphasized that so far. We have said an annuity is a series of fixed payment paid at regular intervals for a given period of time. You can compute its present value by doing it manually. You could do it manually, or you can use this shortcut formula here that helps you to do it all at once. Again, this part of the formula here, we can read it from present value tables, which is what we are going to look in the next recording. So this is an example of that. A borrower is entitled to receive 1,000 per year for 3 years, with the first payment arriving at the end of year 1. When payments arrive at the end of the period, when payments are paid at the end of the period, we call it an ordinary annuity. When it is paid at the beginning of the period, it is called an annuity due. We are going to see that example later on. So here is just an application of that formula. What is the present value? The question is, what is the present value? And because it is an annuity, nobody will usually will not be told it is an annuity. It is you to see it is an annuity. It is 1,000 per year for 3 years. That is an annuity of 1,000 per year. And that is why here we are putting 1,000. Then you put the other part of the formula. You get 2486, which is what we had up there. The same case here, a student will pay 5,000 per year for 4 years. A tuition with payments at the end of the year. Because it is the end of the year, this is an ordinary annuity. Because it is constant payment for a given period, this is an annuity. So we are just going to plug the numbers into the formula, and we get a present value of 16,560. Notice what was paid in total is 5,000 times 4, 20,000. But because of time value of money, it is coming down to 16,000. So I'm going to skip this example. You look at it. The notes are in the portal already. What about the future value of an annuity? Again, we can do it one by one. In other words, let me explain this properly. If you are to go to your circle, every month you put 1,000 shillings. Every month. 1,000 shillings. You realize that is an annuity. You do that for 5 years. you realize you'll have put in 60,000 if you do it for 5 years. 12 months times 1,000, 12,000 times 5 years, 60,000. But because of time value of money, you are earning some interest. So your money will be more than 60,000. This is future value. How much will that 60,000 be? So again, we have a formula here for future value, which works when you have an annuity. An annuity, it must be constant for a given period of time and so on. So we have 1 plus r to power n minus 1 over r. We are going to see that example down here. Let's look at this example. You deposit 1,000 at the end of each year for 3 years into an account earning 10% per year. How much is in the account after 3 years? So let's do that. We are going to say we have 1,000 times 1 plus 10% to power 3 minus 1 over 10%. So notice this is what we have here. This is exactly what has been done here to arrive at 3,310. Notice for 3 years you had deposited 3,000, but because it was earning something because of time value of money, that one results to 3,310. So please attempt this example on retirement planning. An annuity due, on the other hand, it is just an annuity that is paid at the beginning of the year instead of the end of the year. An ordinary annuity is paid at the end of the period. An annuity due is paid at the beginning. What it means is that we have one extra billing period. Let's do this. If payments are made at the end of the year, we are going to have how many periods? 3 periods. But if payments are made at the beginning of the year, we'll have 4 periods. That is the difference. This is what we call an annuity due. This is what we call an ordinary annuity. Payments at the end versus payments at the beginning. So how do you go about this? You simply adjust. You just calculate to get the present value of an ordinary annuity. You simply calculate it, then multiply by 1 plus r, because you have this extra period. You have this extra period. We have that extra period that is there. Multiply by 1 plus r, and you have your answer. So we have these several examples. I don't want to go through them for now. I want you to have a look at that, so that when we look at how to use tables, we are going to have a third lesson where we are going to do examples from beginning to end. We also have the concept of delayed annuities. A delayed annuity is a case where money is going to be paid, but it starts being paid later. For example, this is year 0, year 1, year 2, year 3, year 4. You get nothing here, you get nothing here, you get 300 there, you get 300 there. You see, this is an annuity, but it is an annuity that has started late. It has not started at year 0 here. That is what we call a delayed annuity. I want us to look at how to compute it when we are doing examples in the third video from this one. But you understand the concept. It is an annuity, but that starts not at the beginning, but at a later period. So those are the strategies. Please have a look at that. And an example, we are going to look at an example later on when we are doing, after we do the tables, we have another session for examples that we can look at. On the other hand, we have perpetuities. A perpetuity is simply an annuity that has no end. Somebody is going to be paying you 1,000 shillings every year for the last until forever. That is forever. It will never end. Even after you die, it will be paid to your kids and so on and so on. It will never end. Such things do exist. For example, the British government issued some bonds in the 15th century, I think, which continue to be paid. They pay interest to date. We also have preference shares. Preference shares, when you buy preference shares in a company, they pay a fixed dividend forever. Remember, we say a company is a going concern. It is not going to end. We also have endowments and foundations. For example, if a university has an endowment fund, that endowment fund will pay out a fixed percentage of capital annually forever. So the perpetuity formula is simply C over R, and you can see how it is derived here. Remember, for a perpetuity, our n here is infinity. It becomes infinity. So if you reduce that, it is simply going to be C over R, the amount of money you are receiving every period divided by R. We have a good example here. You receive 100 per year forever, starting in 1 year, year 1. The discount rate is 5%. What is the present value? So it is going to be 100 divided by 0.05. 100 because it is forever. It is a perpetuity. That's it. So why don't we talk about the future value of a perpetuity? The future value of a perpetuity is going to be infinite because it has no end. Note that it has no end, so don't bother about the future value of a perpetuity. It will never end. So here we have a summary of the formulas that we have. Notice we have no future value of a perpetuity because it has no end. It is always infinite. And here are some common mistakes. One of the common mistakes is confusing present value and future value. Be very careful what we are computing. Is it present value or future value? Of course, as when you are beginning, you are likely to make a lot of errors. As you move on, you will be more confident. Please do quite a lot of exercises for that matter. Ignoring the timing of cash flows. Is the payment at the beginning or at the end? We have talked about annuity due and ordinary annuity. Be very careful about that. Using wrong interest rate. For example, somebody tells you that a company is paying, you receive money monthly. I want to give that example. You receive 1,000 shillings monthly, which you invest at 12% per annum. Then you forget the interest is per annum, but the money you are receiving it monthly. You must also convert the interest into per month. If it is 12% per annum, it will be approximately 1% per month. Please make sure you match them so that you don't use annual interest rate to work with monthly payments. So always be careful about that. This is a very, very common error. Very, very common. I think it is one of the most common ones. Forgetting the compounding periods. So when interest is compounding more frequently than annually, both R and N must be adjusted. Let me give you an example. You have you are receiving money twice a year. Somebody gives you 500 in June, 500 in December. The annual and does that for 3 years. Let me do that. This is the 1st June, 1st December, 2nd June, 2nd December, 3rd June, 3rd December. Now, Because you are receiving this money for 3 years, but you are receiving it every 6 months, it is easy for you to start working with 3 years instead of working with 6 periods. We have 6 periods, remember. It is 3 years times 2 because you are receiving twice. So your 3 years now will become 6 periods. If your interest rate is 8% per annum, it should be 8% now divided by 2, which is 4%. So you are going to work with 6% and 4%. This is another example that you are given there in that write-up. So you may ask, whatever we are learning here, is it of any relevance? And I will tell you, in finance, if you don't understand this topic properly, you'll always have problems. Always. Because it is what we use for mortgages and loans, student loan analysis, retirement planning, investment decisions, and NPVs, and so on. So we are going to look at more topics that are coming where we are going to be applying those ideas. So what are the key takeaways? Money has time value. A shilling today is worth more than a shilling tomorrow. Compounding grows money exponentially. At the beginning, the growth is slow, then it explodes all of a sudden. So it is the secret of wealth creation. So invest some money somewhere. 2, don't withdraw the dividends or the interest, just reinvest the money. It is going to compound slowly, then it is going to explode all of a sudden. It is the secret of wealth creation. Discounting converts present value, future to present value. That is what we call discounting. Compounding, on the other hand, converts present value to future values. It is the opposite of discounting. So net present value, you may not know what it is for now, but it is something we are going to cover later, is built on TVM. So timing and risk are also critical. What follows here are some discussion questions that I want you to look at, and some more detailed questions that I want us to look at after we see how to use tables. So please have a look at this handout. It is in the portal. Read it carefully. We are going to have 2 more sessions. One session on how to use tables. Another session where we are going to look at I plan to do around 15 questions that will show us how to go about computing this. The reason I'm emphasizing on this topic is what I told you. It is central. It is the most important topic in finance. Everything else is going to stem from this seemingly simple topic. So please be very careful, read it in advance, and make sure you master it completely. So thanks, and see you in the next lesson.